Good morning, everyone. My name is Munashe, and I'm going to give a talk on the water use of high-performing full-bearing Japanese plums in two major production regions in the Western Cape. So in South Africa, the Japanese plum industry is well established and primarily aimed at supplying plums to the market. Intensive cultivation of the orchards is associated with increased water requirements and particular view of the projected climatic change in the main production areas. Therefore, the availability of adequate water is critical for sustainable production. Plum production is reliant in irrigation, among other factors, to achieve good yield and profit. However, there is little information on the plum water use and plum water requirements. This information is critical for planning in orchards, water licensing, allocation, and irrigation scheduling. So the overall aim of the project was to establish water use of the high-performing Japanese plums across the major production regions in South Africa. And some of the specific objectives was to now relate the established water use with the physical and economic water productivity, and also to determine crop coefficients, basal crop coefficients, which will be used to calculate the water requirements and water allocations, and then lastly to develop models on orchard water use that will be used to extrapolate it to other regions. And then the study sites with two areas in Wellington. The experiments were done on the St. Rivier farm, planted with African Delight, Rubison, and Fortune cultivars. And then in Robertson on Smarts Brothers farm, was African Delight cultivar and Fortune cultivar. So for the data collection, we aimed to establish the soil, plant, and atmosphere continuum. And so from the 2021 up to 2023 seasons, overlapping into 2024, we collected data on weather, soil water content, soil evaporation, leaf area index, crop yields, and irrigation volumes. Surface energy balance, stem water potential, and for the model we used the Hydras 2D model, which calculates the soil water balance and the crop coefficients using the Alan Pereira method. And then for the satellite derived evapotranspiration, we used the Fruit Look platform. So for the results, the 8 covariance flux tower was installed on one of the orchards in Smarts Brothers farm, planted with African Delight cultivar. And these are the results that shows the daily change of evapotranspiration, which is a proxy of the crop water requirements. And as expected, there was low values of crop water use during the winter season, which increased gradually until reaching its peak, the peak summer season, before it gradually falls down towards harvest and after harvest. And the graph to your right shows the calculated crop coefficients, which is calculated as a ratio of the actual measured evapotranspiration and the reference crop evapotranspiration. And then the results for the Fruit Look on your left is a seasonality of the water use of the selected orchards averaged over the 5 seasons, also showing the same trends through the hydrological season from August to July. And then to your right, this is now water use of the same selected orchards, but per season from 2020 to 2022. And you can see the low water use volumes that were recorded for the Fortune orchard. This is mainly because the orchard was uprooted in the 2021 and 2022 season. So the water use after harvest was not taken into consideration. And then we also compared the water use estimates between the micro sprinkler and drip irrigated orchard. And for these investigations, we used 150 orchards over 11 farms. And then the graph shows the distribution of the water use estimates comparing the two. And the overall results showed that micro sprinkler irrigated orchards used more water compared to the drip irrigated orchards by at least 6%. However, the mean and the median of the estimated water use wasn't that much different. I think the difference was like less than 2%. So the main findings on the crop water requirements, since we had the anti-covariance flux tower installed in one orchard, we then validated the Hydras 2D model and the fruit look data set, and then the Hydras overestimated the water requirements, whilst the fruit look underestimated, but overall the two models performed very well. So the Hydras 2D model was then used to estimate crop water requirements in both production regions, Wellington and Robertson, and it estimated more crop water requirements in Robertson compared to Wellington, and overall it estimated more water requirements volumes more than the fruit look. And for the calculated basal crop coefficients using the model, at the initial stage, the basal crop coefficients averaged between 0.82 and 0.98. And in the mid stage, during the peak summer season, it averaged 1.14 and 1.20. And then the crop yield information obtained from the farmers, there was more yield of the plums, various cultivars in Robertson compared to Wellington, with the African Delight cultivar having more yield of ranging from 51 and 52 tons per hectare. So for the crop water productivities calculated from the yields and the water use, Robertson had high crop water productivity, showing that it efficiently used water compared to the cultivars in Wellington. And the calculated economic water productivity depended more on crop yield, fruit quality, cultivar season, and market prices. So this is basically the summary of all the main findings from the experimental period in 2021 up to 2024, which includes the yield of tons per hectares, crop water requirements estimated by Hydras, and fruit look, and also only one season that was the actual measured crop water requirements using the eddy covariance, and then the calculated crop water productivity, the given income from the farms, and then the economic water productivity calculated. So the main recommendations that emanated from the main project, big emphasis on the plum water allocations. So from the given results that I showed earlier on, more water volume is recommended for the orchards in Robertson, with the African Delight recommended to be supplied with 10,000 cubic meters per hectare, whilst Fortune have 10,200 cubic meters per hectare compared to lower volumes of water recommended to be allocated to Wellington. And for on-farm practices, it is recommended pruning and deficit irrigation is recommended to reduce water use with a possibility of increasing yield and fruit quality. And then 3 dripper lines in cultivation ages is not recommended, and this is derived from the results that we got from the Fortune orchard in Robertson, where 3 dripper lines proved to have used more water, which is not really directly proportional to the yield and the quality of the plums. And then this study also recommended further validation of the remote sensing products to improve the model accuracy, and also studies are recommended on crop physiological response, such as the stem water potential, to be able to monitor plant water status and also to track water stress in the orchard. So I would like to acknowledge fellow UWC students who were part of the project, and Hot Grow and WRC for funding the project, the reference group members, ARC for providing weather data, the farmers from St. Rivier and Smas Brothers, Western Cape Department of Agriculture, and the Fruit Loop team for allowing us to use their platform. Thank you.